I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast that helps you understand the chemistry of your everyday life.
Okay, Jam. Here we go again.
Again?
After our last skincare episode on retinol, we got a lot of good reviews. Both Nikki in and Sam in said they wanted to hear more. I know Vietnamnet G also would. She asked me for a whole series a long time ago. So here we go. We're doing some more skincare.
Okay. All right.
So again, this is not medical advice.
Right.
And always consult with a doctor before you try a new product. But what we're going to talk about today is hyaluronic acid.
Okay.
So that's another sort of skincare buzzword right now. I first noticed it because it's in some of the products. I think it's a sunscreen I put on in the morning. I heard the doctor talking about it on the dermatologist website that I sometimes follow. And I just had to ask, what's the deal? Is it magical? Is it as amazing as retinol? We got to find out more. So the short answer to me is it's not as magical as retinol when it comes to skincare.
Okay.
But it's more magical than retinol in other ways.
Okay. Interesting.
Okay. So a few weeks ago, I was with a group of people, and this older woman told me that she thought science was just amazing because she had heard about this serum that you could get from a rooster's comb. You know, the little red thing on top of a rooster. And she said it helps with arthritis and it's just amazing. And I thought that she was kind of getting duped a little bit.
Oh, yeah?
I was like, there's no way.
Yeah.
It just doesn't sound real.
Yeah, that does not. That sounds very snake oily, you know?
Oh, 100%. But guess what?
Is it real?
100% real.
What the?
And she was talking about hyaluronic acid.
Okay.
Okay, so I was wrong. And she was right. And I didn't even find that out because I cared enough to look it up. I found it out on accident.
Oh, okay.
So I got humbled by this week's episode. So hyaluronic acid is, I'm so excited about this too. It's a polymer. I love polymers. So it's a large molecule made up of several smaller molecules. And it's made up of two sugars that alternate. So it's like sugar A, sugar B, sugar A, sugar B, sugar A, sugar B.
Okay.
It's used in cosmetics and the medical field. It was first isolated from cows' eyeballs.
Okay.
Ew.
Weird.
Yeah. Then it was subsequently found in roosters' combs.
Okay.
Where I got humbled. And it's in our eyeballs too.
Okay.
Seems to be the main component of the jelly center of our eyeballs.
I mean, you do need those eyeballs though, so it's not like we shouldn't probably be taking those out.
That's true. Don't take them out.
Yeah, and cows need their eyeballs too.
Yeah, well, maybe not cows that aren't living anymore.
That's a good point.
Same things with roosters who aren't living anymore.
Right. But they might even not need their combs while they're alive. I mean, what do they do? You know?
I have no idea what a rooster's comb does. That's biology for your life. Any biologists out there want to let us know? Please do. So not only is hyaluronic acid in our eyeballs, it also exists in our bodies in a lot of other places.
Okay.
On average, humans have 15 grams of hyaluronic acid in our bodies.
Weird. Okay.
It's kind of a lot.
Interesting.
It does all kinds of good stuff. It's in the umbilical cord of babies. It's in our skin. Does a little bit of tissue repair possibly in our skin. And it's the fluid that helps it's in the fluid. It's not every part of the fluid, but it's part of the fluid that helps our joints move.
Okay.
But also it seems like maybe it helps cancer metastasize once things have gone wrong. So that's kind of sad.
Yeah.
But it does all this other good stuff too. I think that's part of how cancer just takes things and uses it for its own terrible purposes.
Right.
And it didn't seem like using hyaluronic acid has been linked to cancer at this time. I think it's just the body uses the hyaluronic acid that already exists once cancer has compromised it.
Okay.
That was my perception. Who knows if they'll find out more in the coming years. You always gotta kind of be careful. But I doubt if it's in our eyes, it's causing a lot of cancer.
Right.
You know.
Yeah.
It's already there. We got 15 grams of the stuff.
Yeah.
So generally in cosmetics, hyaluronic acid is used as moisturizers. And it'll be classified as a high molecular weight or a low molecular weight.
Okay.
this is your chemistry lesson for today.
Okay.
And this is an aspect of polymers and actually of chemistry that we have not talked about yet.
Okay.
You probably remember it from high school chemistry.
Okay.
And for any of our listeners who have taken high school or college chemistry, you've probably also used this concept before as well. But just to jog your memory, molecular weight matters a lot. Mm-hmm. It's when you add up all the atoms in a molecule. Mm-hmm. So say you have 6 carbons, 6 hydrogens.
Okay.
So you take the molar mass of each of those atoms, and that is the weight of a mole of this atom.
Okay.
So I think carbon is 12 grams, mm-hmm. and hydrogen is about 1 gram per mole.
Okay.
So if you were trying to figure out the molecular weight of benzene, you'd multiply 12, the molar mass of carbons, by 6, the number of carbons.
Okay.
And then you'd multiply 1, the molar mass of hydrogens, by 6, the number of hydrogens.
Okay.
And then you'd add those numbers up.
Okay.
And that is the molar mass of benzene.
Okay.
Okay.
That's the stuff that really always threw me.
Yeah.
In chemistry. Gosh.
Well, what's useful about it is then you know how much a mole of this new molecule weighs.
Okay.
Okay. In polymers, you've got these repeating subunits that are A, B, A, B. Mm-hmm. The molar mass of a polymer will tell you if you have a lot of repeating subunits or less repeating subunits.
Okay.
Because if you have, A that weighs 100 grams and B that weighs 200 grams, mm-hmm. if you have a 10,000 gram polymer, that's a lot of A's and B's. If you have a 300 gram polymer, that's just one A and B.
Okay. Got it.
That's just a monomer. I was just throwing those numbers out there to give you an example. So that's really what they mean when they say high molecular weight and low molecular weight. They mean long polymer chains or short polymer chains.
Okay.
So that's your big chemistry lesson. And when I was an organic chemist, and organic chemists everywhere, use molecular weight all the time.
Okay.
If I'm trying to figure out how much of something I need for a reaction, if I'm trying to figure out how much I produced based on a reaction, I used the molar weight of things every single day. So this molar mass, molecular weight, this is something that really is a huge concept in chemistry. Mm-hmm, mm-hmm. But we don't use it for this kind of everyday life application very much. So I was kind of excited when I saw it come up today.
Okay, got it.
So that's that on high molecular weight, low molecular weight, what it means. Long polymer chains or short polymer chains.
Okay. And so this acid can have both?
Yes. So hyaluronic acid could have a lot of repeating AB, AB, AB units, or it could have maybe just the single monomer, AB, or it could have AB, AB, these shorter chains.
Okay, got it.
I think those shorter chains are called oligomers. So the monomer is just the one unit, mm-hmm. AB. Mm-hmm. The oligomer is shorter chains.
Okay.
And the polymer technically is a longer chain, I think. I did not look that up before this episode. Mm-hmm. But so the high molecular weight, the long polymer chains.
Okay.
What that does in cosmetics is it sits on top of your skin. It doesn't go into your skin or anything. And hyaluronic acid has this special property. It loves to attract water to itself.
Okay.
A big chemistry word for that is hygroscopic.
Oh, interesting.
It grabs water and attracts it. So hyaluronic acid will sit on your skin and lock in the moisture in your skin, and it works very well as a moisturizer.
Oh, interesting.
There is no question about that. Uh-huh. Everybody agrees. Uh-huh. So that's a great thing about a high molecular weight hyaluronic acid.
Okay.
And the high molecular weight means it's got a long polymer chain. So this makes sense to me that it almost, I imagine it forms like a face mask kind of acid on your skin. You've got these long spaghetti chains of polymer just sitting on your skin, acting as a barrier. It's not letting water leave, and it's attracting more water.
Nice.
That's how I envision it. Now, shorter hyaluronic acid chains, these low molecular weights, they have less units, so they can actually penetrate your skin,
Okay.
similar to what retinol does.
Oh, okay. Gotcha.
And there's actually some mixed reviews on this. I saw some people say that there's evidence. I saw some people say that the evidence is weak.
Mm-hmm.
All of them are pretty reputable sources. I think there's just not a huge consensus. And a lot of these were from about the 2015 to 2018 range.
Okay.
Those shorter oligomers, the low molecular weights of hyaluronic acid, seem to be able to penetrate the skin and ultimately prompt the creation of more hyaluronic acid.
Okay.
That's already in your skin.
Okay.
And that could help with skin elasticity. It could help with skin repair. It could do a lot of stuff like that we've talked about that retinol also does.
Okay. Interesting.
But there's not a lot of clear evidence. Even the dermatologist that I follow, he talked about how high molecular weight is well known as a moisturizer. Low molecular weight can penetrate the skin, but it really, he said, maybe it would just temporarily plump the skin. Where some other ones I saw said it could maybe help with tissue repair. It just seems like what the true function of the lower molecular weight, the shorter chains can actually do is questionable.
Okay.
And when things transport the skin like that, you have to make sure they're not bringing something along with them that you don't want to bring into the skin.
Right.
So I have some questions about the lower molecular weight and how much it actually will do.
Yeah.
It doesn't seem that it's super dangerous as long as it's not paired with anything dangerous to bring through the skin with it.
Right.
But it also, I don't know if it really does much. What it definitely does, higher molecular weight, hyaluronic acid definitely moisturizes your skin.
Nice. Okay. Cool.
Okay. But also, hyaluronic acid can be injected into your joints to aid with arthritis.
Okay.
And it can prompt more hyaluronic acid to be made, like we talked about. And that is a better treatment than cortisol steroids because it has less side effects and it can prompt the body to start helping itself.
Okay. Interesting.
I read one chemist replied to an article about this in Chemistry and Engineering News, and he said 3 shots of hyaluronic acid, the gel that they inject into your joints when you have arthritis, actually made it to where he has barely any pain anymore.
Interesting.
Which that's anecdotal, but it is a treatment that they use for that. And it's definitely better for you than steroid injections.
Right.
And I read in one article that hyaluronic acid can be used topically to help people, so applied to the skin is what topically means, to help people with diabetes who they sometimes have trouble healing wounds if you have diabetes.
Yeah, right.
And because there's some aspect of hyaluronic acid that is involved in skin repair, they can smooth it on and your skin will be helped and aided in the repair even if you have diabetes, and that's something that's harder for your body to do.
Interesting. Are both of those the high molecular weight?
I couldn't tell.
Okay. That's interesting.
Because it wouldn't have to penetrate the skin.
Because you're putting it, the first one you're injecting it, and the second one you're putting it on
the wound.
On the wound, yeah. Which is open. So.
Yeah.
Interesting.
I know.
Wow.
So all this is to say that hyaluronic acid is a polymer. It has different properties based on different molecular weights. The anti-wrinkle, anti-aging properties aren't clear, but it's a good moisturizer and it also does other amazing things. And also don't discount what you hear people say necessarily about rooster's combs.
Right.
So yeah, this episode was all about how wrong I was and how excited I was to find out all these really cool properties about hyaluronic acid, which again, a lot of times when I hear about skin products or cosmetic products, I assume it's a lot of mumbo jumbo. And really this is something that is in our bodies and that is very useful in terms of different applications.
Yeah. But I think there's probably something to be said for you having a healthy level of skepticism, because there are also plenty of situations where people are, preying on people not knowing anything about science.
That's true. Yes. I try to really look and check. And that's what I had appreciated about this doctor that, puts out these videos, even though, they're just on YouTube. He doesn't always give his sources, but a lot of times he does give his sources and he references studies and things that he's learned in medical school. And so it feels similar to what we do here on this podcast. He cited a paper. I wanted to share this with you guys about moisturizers and allergens and how the level of allergen is related to cost of moisturizers. And one dermatologist did a study on this and found that actually more expensive moisturizers had a higher propensity for more allergens. So that made me laugh. I linked to it in our show notes. So
interesting.
So more money does not equal better product.
Yeah.
Which I also appreciate about this because I feel like I'm learning what is worth spending money on and what isn't.
Right. Interesting. And can you remind us of his name or how to find him?
Yes. So he on YouTube, those are the more comprehensive videos. I linked to the one where he talks most in depth about hyaluronic acid. And it's Dr. Lee. Doctor with an L-Y at the end.
Oh, nice. Like an adverb.
Yeah.
Got it.
Like an adverb, yes. And his name is Dr. Shah. If you just type in Dr. Shah, S-H-A-H, dermatology, he'll show up. Because he's on all the platforms. And he's got like 7 million followers on TikTok. So he is very well known. But I'm just so excited because he's well known for sharing good science.
Yes. Yep.
So, and that's what we love here at Chemistry for Your Life. So we want to promote that. I'm very excited about that.
Yeah, that's awesome. Thing. Very cool.
So do you want to take a stab at explaining molecular weight?
Yes.
And how this whole product works?
Yes. I'm going to try my best not to even use the word mole so that I can try to put it in a part of my brain that doesn't get scared. So just to start, the things that stuck with me about molecular weight were, especially when it comes to like the different kinds of polymers and stuff, is that if it's a high molecular weight, means that it has longer chains of the alternating like different molecules for the polymer, right?
Yes.
So like AB, much longer, whereas a lower molecular weight would have just shorter chains or whatever of the polymer. What I thought of that I think is somewhat close. So you talked about the difference being when we put that on our skin, it's like having a really solid coat with long polymer chains when we have the high molecular weight, and not as much that way with the low molecular weight.
Right.
The first image that came to mind for me was the different kinds of plywood.
Oh.
So there's the kind of nicer plywood, which is lots of layers of wood, meaning that from across the entire piece of wood it's one layer.
Yeah.
Even though it's thin, it's still continuous.
Yes.
And then another layer, and they're all stuck together with glue.
Yes.
But you also have the plywood that is maybe it's not even technically plies of wood, but it is all these just chunks, smaller chunks
just pushed together.
That they've pushed together. And in both those cases, if you have those sheets of plywood endure like, weather and rain and whatever else, it becomes pretty evident which one's better. Because if you have lots of just different pieces and stuff, we had some pieces of plywood that we left out in our backyard at an old house. It starts coming apart where those chunks are starting to come apart. And so instead of having one solid layer, it comes apart in all these different places because it's not a long continuous piece. And so obviously that wouldn't quite relate to our skin in the same way, but a solid layer does, versus kind of smaller sections of polymer that don't quite create that continuous layer on our faces.
Yeah.
Is that close to?
I think so. Yeah. I couldn't imagine. I think that's a good analogy. I have this visual in my mind of, how sometimes for movies they'll paint on people's faces, and it's like all those lines and little things. It looks like veins on your face or something. Sort of picture that, but I think yours is better.
Yeah, I was trying to think of something that like I know I've had experience with buying basically the wrong plywood. So I was like, all right, it would have been better for me to buy the nicer one in that case.
Or maybe even, if you imagine your skin like a filter, bigger pieces aren't going to be able to go through the filter, but smaller silt-like pieces will. So the bigger pieces will form a layer there in your filter, and the smaller pieces will come through. And so in your skin, the smaller pieces come through and do something in the underlayer while the bigger pieces form the layer on the outside, kind of.
Dang, if I think about it long enough, I could definitely think of a coffee analogy there with filtering. But
oh, yeah, definitely.
that might not be more simple. It might just be another way.
For example, I haven't been grinding my own coffee, but I've been trying to use French press. And there's all these little pieces.
Oh, yeah.
They make it to where they transport through the filter and they get in my coffee.
Yeah.
But if you have bigger pieces, that doesn't happen. I mean, it's not the same as moisturizing, but I think we can all understand the longer, bigger pieces won't go through a barrier in the same way.
Yes.
And they'll form a layer of protection and moisturizer.
Ooh, like how motorcycles can weave in and out and around traffic.
Yeah.
And get through.
Because they're so small.
Even though all the cars are jammed up and packed in together.
That's a good one, too.
Whoa.
The little, shorter, lower molecular weight molecules or motorcycles getting into the underlayer of your skin and doing who knows what. Not us. We don't know yet.
Yeah.
Something cool.
Yeah, maybe good, maybe bad. Who knows?
Maybe good, probably good to some degree. Who knows? And the larger molecular weights, they're stuck in traffic and they're creating a barrier so that moisture won't leave your skin.
Yeah.
You've got little cars parked all over your face if you put that stuff on there. And inside your eyeballs, probably.
Right.
Well, that was a fun one. I really enjoy this one. I got so excited. I love it when I'm wrong. I think it's so funny that I was just assumed that woman was totally off base and then I was totally off base.
Yeah.
It's always good to be humbled and reminded. And I thought it was just a really cool application for the arthritis and the healing the wounds. It's magical, really. So yeah, I thought it was just a really fun episode. So I was really excited about it.
Yeah, me too. That's interesting. And all the skincare stuff that I've never even really ever cared about for the most part. It's like now there's so much more. It's a whole world I didn't really realize was there, I guess. But
me too. Yeah. And one that's scientifically founded that I just kind of ignored.
Right. Yes. So is it time to talk about something cool from our week this past week?
I mean, I thought the skincare stuff was pretty cool, but yeah, definitely.
Yes. Well, something maybe potentially non-scientific.
Non-scientific cool things. Yeah. I mean, everything is chemistry, but sure. I'll give it to you.
So mine's kind of short, but my son turned 1, which is kind of crazy. Hard to wrap my head around.
Crazy.
Yeah. We are going to do a separate kind of celebration for him at a different day. But one thing we did on his actual birthday was we went on a walk to our favorite little coffee stand, The Mug, which has existed almost the same amount of time that he has. So
that is crazy.
And so we did that. We used to do it a lot whenever he was first born and was on maternity leave. So
there's some pictures of me visiting you guys there that we posted on social media. Yeah.
Yep. We love The Mug. So check it out if you're in the Denton area. And then we're trying to figure out something kind of cool experience to take him to. And we thought about a zoo, but it's very hot. So unless you go super early or maybe like late or whatever, it's very, very warm. So we
very hot.
Took him to an aquarium and got to show him the big and small and colorful and weird fishes and stuff and creatures.
Did he respond to them? Did he seem excited and interested in them?
He did. I think for about half the time we were in there, I think he had an attention span to be interested for the first half. And then it got kind of boring.
Yeah.
The differences between the fish and creatures after a little while was not significant to him.
Yeah.
But it was pretty cool. And there was at least like quite a few large fish or, sea creatures that moved in ways that excited him.
Oh my gosh. Yeah. That would be amazing for the first time as a baby.
Yes. And he got to see, there were a few there's like a sea turtle that really wanted to hang out near the glass. And so he felt like he got to be like right by it. And then we also they have a little tunnel that you can walk through where the water goes over. And a pretty large, I can't remember the name of it, fish was swimming like right over and around and stuff. And so it was just kind of cool to feel like you're like in it.
Yeah.
So he definitely responded to that. So I think there's just enough there for his age to be at least interesting.
Yes.
For about 20 minutes. And then he kind of got bored.
Did you have fun?
Yes, it was really fun. It was a lot of fun.
Well, congratulations on being a parent for a whole year. You made it, and COVID, no less.
Yeah, that's true. Yeah.
So very impressive. And you so far are raising a very cute, very fun baby. So good job.
And I don't know how much credit I can get for that, but I'll take it. So
speaking of being a parent, my happy thing from this week is about my one area of parenthood, which is a plant parent.
Uh-huh.
I don't have a baby.
Is it called, what is that called though?
Like a plant mom, plant parent.
Like, I don't think it's a real thing though, right?
Same thing as people saying dog mom, you know?
Oof. Let's not go there. That's yikes. But I mean, they're like animal husbandry is a phrase for like, you know what I mean? Is there something like that for plants?
I don't know.
Okay. I was just curious.
But I'm only an amateur one at best. But I've always been a succulent person. That's the thing I can keep alive most easily. My friend Molly and Miriam are slowly plotting to get me to be a houseplant person and not just a succulent person. So for my 30th birthday, Molly got me a pothos, which is the ivy type plant that's really easy to keep alive. And your wife got me a ZZ plant, which is also really easy to keep alive. People are just slowly, they're giving me plants that act a lot like succulents.
Yeah.
But yesterday I walked into my office and there was a Pilia plant, which is really cute. And I've been wanting one for a long time. And she has one that put out a smaller plant. So she just took the small plant and got it established and then left it on my desk. We have just swapped plants back and forth. I gave her a little succulent that I thought would be a good introduction into the succulent world. So I was very excited to see my Pilia there. It is so cute. I'll post a picture of it. Actually, I'll just post pictures of all my plants if you guys want me to. I love them. So that was my happy thing. As soon as I saw it yesterday, I was plotting about sharing it in this week's episode.
Nice.
So thanks, Molly, for my cute little baby Pilia plant. I love it. And I also love the pot it came in, and I'll try to keep it alive. And also thanks to you, Jam, for coming and learning about hyaluronic acid. This was so fun.
Anytime, dude.
And thanks also to all of you guys, all of you listeners, for listening and being excited about science. I can't believe we get to do this. It's such a fun experience. Every single week, I'm newly excited and fascinated by chemistry. And that's thanks to you guys.
And thanks for turning that fascination into teaching us these things about chemistry in our everyday lives. Melissa and I have lots of ideas for topics like this, but want to hear from you. So the things you wonder about, the products you use every day that you're like, is there chemistry happening in here? There probably is. So let us know if you're curious about that. Gmail, Twitter, Instagram, or Facebook are great places to reach out to us. We are Chem for Your Life. That's Chem, FOR, Your Life on all of those platforms. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to S. Navarro and In Newell, who reviewed this episode.